estimated editor and editorial board members of International Journal of Electrical and Computer Science. And first of all, I am giving a good thanks to the editorial board and the of the International Journal of Electrical and Computer Science. And I'm Pinakshi Panda, a research scholar of C.B. Raman Global University. And my topic is, my manuscript title is Ant Lion and Colony Optimization, Integrated Ensemble Machine Learning Model for Effective Cancer Diagnosis. And my paper ID is 36737. And paper is accepted for publication in International Journal of Electrical and Computer Engineering. So for that, I am give a grateful thanks, heartily thanks to the editorial board of International Journal of Electrical and Computer Science. And my topic is basically based on the cancer disease detection, like ant lion and ant colony optimization, integrated ensemble machine learning model for effective cancer diagnosis. So as we know, cancer is a very dangerous disease, and now it is a cause of the death, of people's of lack diagnosis, lack detection of the cancer disease. Okay, so machine learning is playing a vital role in detection of the cancer. Machine learning is playing a vital role in detection of the cancer, and machine learning having the in the various field, not in the disease detection. In various field, there are the application of machine learning. So I am trying to design a small model for detection of cancer disease. So my topic is ant lion and ant colony optimization, integrated ensemble machine learning model for effective cancer diagnosis. And my table of content is introduction, objective literature survey, material and methods, empirical analysis, conclusion, and reference. Basically, as we know, the cancer is long been a leading cause of death worldwide, making it as a significant global public health concern. So several diseases resulting from the uncontrolled growth and spread of abnormal cells. So it exports a significant impact on the overall well-being of general populations. So as we in the statistical analysis of the World Health Organization, National Cancer Institute, the number of the cancer diagnoses in 2018 exceeded 18 million, resulting in over 10 million deaths attributed. And in 2019, 9.6 million individuals are in cancer on the global scale. And in 2021, World Health Organization reported that 9.9 million individuals died due to the cancer. So cancer is a dangerous disease. So early detection and diagnosis save a life. So we are trying here in our manuscript to develop a model. In our research work, we develop a model that is based on the ALO feature selection based model, and which is we are considering the microarray dataset. So for the cancer disease detection in the medical industry, there are the two types of dataset available. One is biospheric dataset, another one is microarray dataset. Biospheric dataset is not containing any genetic information, but microarray dataset is containing the genetic information. So microarray dataset containing genetic information, and they contain the genetic information regarding the genetic information regarding the cancer. So the accuracy of the model is utilizing the biospheric data is hard to accept due to the limitation of dataset, because biospheric data is not containing any genetic information, but microarray dataset is containing genetic information, and which is used. This dataset is used for giving the good result, good accuracy in cancer detection. So microarray is a highly efficient method for examining the DNA expression in cells or tissues across the entire genome. So as two sort of the data sets can be employed in cancer diagnosis, both the microarray data and biospheric data. The biospheric data set does not encompass the patient genetic information, but the genetic information that is containing for the diagnosis of cancer, that is the microarray data set. So microarray data set, one disadvantage is that the microarray data set is containing the high computational cost Okay, and also we are getting the high accuracy from the microarray dataset. So microarray dataset is actually small sample size and the high dimensionality. High dimensionality means the feature is very less. High dimensionality means the microarray dataset is a small sample size SSA problem. That is ML based model is applied directly to the microarray, and small sample size means number of the patient is less, and the high dimensional means the number of the feature is more. Number of the feature is more means the number of the genetic information, patient genetic information that is containing is more. So high dimensional issue has to be reduced fast before applying to an ML classification model, and the dimensionality reduction technique can be classified into two groups. One is feature selection and feature extraction. Feature selection, it removes the irrelevant gene expression, and feature extraction, it will add some feature, a few feature from a large number of original feature through the linear and non-linear combination. So as you know, the microarray dataset having the high dimensionality means the number of the feature is more, the genetic information that is containing the attributes that is more, and the sample number of the patient is less. Our objective is to reduce the number of the features for getting the more accuracy. Because for the cancer detection, we are needing the genetic information that is contained in the microarray dataset. But the disadvantage is it has the high dimensionality, means the number of the feature, number of the genetic information is more. So that means we have to reduce that noisy data. Whatever the features are there, we have to reduce according to our target value. Then we are getting the more accuracy. So for that, in the current work, we have to propose an ensemble model for cancer diagnosis. And in the proposed work, adopt two meta-heuristic, one line optimization and uncolony optimization to select the relevant feature from a microarray data. So there are the three ML-based classifier are applied along with the voting and averaging ensemble technique for classification purpose. So the objective of the current work can be summarized. That is, first we have to use the ALO and SEO as a meta-heuristic feature selection method. After that, we are implementing the classifier as a base learner, support vector machine, AdaBoost, XGBoost, random forest for the initial prediction. Then we have to apply the voting and averaging ensemble technique to form an ensemble ML-based diagnosis model to evaluate the proposed model over three kinds of cancer microarray dataset. Okay, we have to evaluate the model over the 4 cancer microarray dataset, and to measure the model's performance, we have to using the accuracy, precision, recall, specificity, F1 score, etc. So this is my literature survey. That is the feature selection algorithm. We have to use the literature survey here. That is the in the one that is in our reference. Feature selection is use ICA, CS, ABC, and GA, and the classifier is in A-based, and it is done under the colon long prostate acute leukemia. And in the second reference, that is the multimodal SBM, KNN, and ELM, and sub-voting ensemble technique we are using, and it is over the brain, colon, leukemia, lung, prostate, breast, ovarian. And in the 3 also we have to taking the classifier as SBM, random forest, DT, KNN, and it is work on the breast cancer. And in the 4 we are using the classifier as LR, your KNN, SBM, MLP, and DT. That is also voting technique we are using, and it is cervical cancer we have to using this. And also in the 5, 6, 7, 8, that is also we have to use the classifier, fuzzy offset, naive base, and fuzzy offset as a classifier. And it is also we have to see over the different cancer datasets. So this is our material and methods we are using in our research work, proposed model. So dataset description, ovarian, long, breast, leukemia, 4 dataset, microarray cancer dataset, who is having the binary class, either 0 or 1, that is 2 class, that is binary. And the number of the feature is in ovarian 15154, and number of the sample is 253. And in lung 12533, and the number of sample is 181. Breast 24481, 97 is a sample. Leukemia 7129 and 72 is the sample. So here the proposed method adopt the 2 phase of the cancer classification, including the 2-phase feature selection classification process and the feature selection methods. ALO and SEO are applied to select the subset of initial features. Second phase is what? Now we are using the base learner, SBM, XGBoost, AdaBoost, and your random forest for initial prediction, and in the initial prediction, voting and averaging are applied to make the make the model, and we have to comparing over the voting and averaging for getting more accuracy. So this is the steps. First, we have to consider the microarray data for the normalization, and the normalization technique we are using here for standard scalar normalization method. Then the data set is split into two parts. One is training, one is test. That is in the ratio 80-20. And the train data apply two-stage feature selection process, apply the ALO feature selection algorithm, and the technique we are using in ALO initialize the ant and antlion population with maximum iteration Tmax. Then calculate the fitness function of the both population using the k-fold cross-validation method with an accuracy as a key for the fitness function calculation. Then fit ant lion summation of IU of 1n, accuracy I by n with n number of the folds. Identify the next position of the ant and antlion. Recalculate the fitness function. Then we have to, if fit old is greater than fit new, then replace fit with the fit new. Next is we have to update the fit until t is equal to t max, update the feature set, apply the SEO feature selection algorithm. Then we have to do the initial, the ant population maximum iteration t max, calculate the fitness function, both population using the k-fold cross validation. Then we are using the formula, identify the next position of the ant, recalculate the fitness function. Then FIT old is greater than FIT new, then replace the fit with the fit new, update the fit until t is equal to t max, update the final feature for the phase 2 of the proposed model. These are the two phases of the SEO and ALO feature selection algorithm we are applying over the microarray dataset. Then next, after applying the base learner, SVM, random forest, XGBoost, AdaBoost, then apply the ensemble classifier, voting and averaging, then apply the test data to train model obtained from step 7, evaluate the performance of the train model. This is our proposed model, the working principle. So we have to taking the cancer data set, dividing it. First, we have to normalize it by using the standard scalar method. Thereafter, we have to dividing the test and training, 80-20 basis, 80-20 ratio. After that, we have to using the ALO-based feature selection and SEO-based feature selection, two phase of the feature selection for reducing the dimension of the data set. And after that, we have to do the we have to apply the SVM, AdaBoost, XGBoost, and random forest as a base learner. And after that initial prediction, we have to do then ensemble classifier. We are using voting and averaging, and individually we are using the voting and averaging, and we are comparing the result of the voting and averaging. Our purpose is to getting the more accuracy. And then after the test data are the raw data, and which is applied to the train model to test the robustness of the model, our proposed model. Then we have to performance evaluation, that is the result evaluation. So there are the two type of phase of the ALO and SEO we are using. That is the ant-lion optimization algorithm and ant colony optimization algorithm for the feature selection, two-phase feature selection. So here the ant-lion optimization ALO method is derived from the predictory strategy used by the ant-lion, and where captured the ant by constructing the conical and within the context of the ALO. So there is a formula that is here for calculating the ant-lion optimization technique. And in ant colony optimization also SEO, we are using the heuristic optimization technique that emulate the behavior of the ant issue, and the method work on a graph representing the issue with the nodes representing the potential solution, connection between the solution. So there is a formula is there. So we have to evaluate according to the algorithm the features, and we will be reducing the feature of the microarray dataset after the normalization. So, and voting and averaging we are using. Voting is the ensemble technique, and which is enhance the forecast the accuracy by aggregating the result. And these strategies are especially efficient, and when separate models possesses distinct strength and limitations, since they may mutually enhance the result in more realistic and precise forecast. A voting ensemble involves using the numerous base models such as decision tree, support vector machine, and neural network independently. And the averaging is ensemble techniques are find out in the average or mean ensemble combines the prediction of the base models by calculating their average. Then this is the result analysis. Here we have to, in this our study research work, we have to use the 8 GB of RAM window, Windows 11 OS, Intel i3 processor, 26 GHz, and proposed model analyzing in Python environment, Anaconda, navigator, and we have to evaluating our performance of the model, machine learning based evaluator parameter, that is the accuracy, precision, recall, F1 score, and specificity. So here we have to calculating the TPA, true positive rate and false positive rate, true negative and false negative. As you know, true positive accuracy is calculated true positive plus true negative by true positive plus false negative plus true negative plus false negative, and precision is true positive by true positive plus false positive. Recall is true positive by true positive plus false negative. F1 score is true positive by true positive plus 1/2 false positive plus false negative, and specificity is true negative by false positive plus false true negative. So true negative is what? The patient not suffering from cancer showing negative. True positive means the patient suffering from cancer showing the positive. And the false positive means the patient is not suffering from cancer but showing the false positive. And the patient who is not suffering from cancer but is showing the false negative. So if the true positive, true negative rate is more, then we assume that our model is accurate. Accuracy is more. Our model is good. So this is the result analysis of hybrid model with the ALO and SEO feature selection. So we are using it over the 4 dataset: ovarian, long, breast, and leukemia cancer. And a hybrid model we are using for ALO and SEO, that is the accuracy is the SBM, random forest, XGBoost, DataBoost, SBM. These are the accuracy, precision, recall, F1 score, and specificity. Then we have to result analysis using the voting ensemble technique with ALO and SEO feature selection over the 4 dataset. That is the ovarian, your long, breast, and leukemia. So in the ovarian, that is the accuracy is 98.44, long cancer 99.08, and breast cancer 98.6, and in leukemia 97.27. And in case of the appraising ensemble technique, ALO and SEO feature selection, in the ovarian, long, breast, and leukemia, the accuracy is 96.33, 97.36, 96.20, and 95.54. And this is the result analysis of the accuracy. In the accuracy dataset, we have to take in 4 dataset: ovarian, long, breast, and leukemia. And the accuracy is in the percentage, and it is the comparison between the voting and averaging the accuracy of the 4 datasets. The next is your precision. Comparison of the dataset, 4 dataset: ovarian, long, breast, and leukemia. The precision calculation graph, this is. And next is your recall comparison, that is ovarian, long, breast, and leukemia. Then F1 score comparison over the 4 dataset: ovarian, long, breast, and leukemia. And this is the specificity of the 4 datasets. We have to calculate. This is the receiver operating characteristic ROC curve. We have to calculate the false positive rate and true negative positive rate. And this is the ROC curve for ovarian cancer. This is the ROC curve for lung cancer. This is the ROC curve for breast cancer. And this is the ROC curve for leukemia cancer, in where the 0.973. And here AUCH in the case of the breast cancer, the AUCH 0.978. And in case of lung cancer, that is the 0.99. And in case of the ovarian cancer, that is 0.985. This is the accuracy comparison with the other literature survey. Because we are taking the literature survey, our proposed model we have to comparing with other literature survey. So in the reference number 1, the leukemia cancer is 92.33. It is acquiring the accuracy. And in the as the accuracy we are taking as a key parameter. In the 2, that is ovarian 95.65, long 93.56, and breast 84, and leukemia 91.36. And in the 3, 97.2 in breast cancer, and in the 5, 92.7 in the leukemia cancer. In the 6, 86.17, and in our proposed model is getting the more accuracy. In ovarian cancer 98.44, lung cancer 99.08, breast cancer 98.06, leukemia 97.27. So now we'll come to the conclusion. The current work aims to develop an ensemble-based cancer diagnosis model with ALO and SEO as the feature selection algorithm, equipped with 4 types of the machine learning classifier: SBM, random forest, DataBoost, and XGBoost, with 2 ensemble classifier, including voting and averaging. An experimental study done in this work shows that the voting classifier outperforms the averaging classifier with the accuracy 98.44 and 97.27 in ovarian cancer, breast, and leukemia. And the ROC and AUC value voting classifier is 0.985, 0.99, 0.97, 0.93 for ovarian, long breast, and leukemia cancer dataset. So here we are developing a cancer for detection of the cancer, and our research work is basically based on the machine learning and suggests that the field of study and the medical community and may undergo a technique improve the realistic and capacity to identify the cancer early, and the high accuracy, sensitivity, and specificity level suggest that this might result in better patient outcomes. So in the future also we have to use this by taking the multiple number of the data set, multi-class data set, and also we have to use using the deep learning technique for enhance our research work. And also our research work, I hope it give the benefit to society, resource community, and resource allocation, and efficient healthcare delivery. Okay, thank you. Thank you so much.